It's a bright sunny day, isn't it? Have a look at this picture. Does it look like a roof hanging out to dry? No, it isn't. This is a metal roof blown off in a storm. The roofs are often considered as only a building envelope. However, they are the first line of defense during extreme wind events, such as cyclones or storms. There is a prediction of increasing intensity of cyclones. During such events, the roofs are vulnerable to uplift or suction. There is an increasing applications of metal roofs, in some cases occupying market share up to 70% in New Zealand. Therefore, their resilience become important to reduce risk to public safety and infrastructure. However, current studies are fragmented. My research focuses into 3 F's: the failure mechanism, the failure capacity, and the failure probability. The failure mechanism and the failure capacity are determined using large-scale experimental testing and calibrated numerical models. The data obtained from them is then fed into a probabilistic framework that spits out the probability of failure under various wind conditions. So far, the study has established improved understanding of how and why roofs actually fail. Progressive unzipping is real, means a single connection failure cascades to overall roofing failure quicker than we thought. The study also established that design equations are capable of predicting failure loads within 20% accuracy. Also, better failure probability estimation. So, in short term, the study proposes design guidelines and recommendations as well as likelihood of failure. In long term, it will help design safer roofs, improve building standards, and reduce losses from extreme wind events. So next, when you look at a roof, think them as a first line of defense, not only an envelope. Thank you.
Thank you. In your opinion, is it an engineering issue currently, or is it a building code issue that the roofs fail? Is there something you're looking to impact as well?
So currently, it's more into engineering point of view, that the design of the roofs and as far as the products that are there, they're not that compliant, and we don't know actually how these fails. Like, one of the key findings was, generally if we think that, oh, let's say a roof has 100 connections, so maybe if one connection fails, it can sustain. But what we observed is quick unbuttoning. Like so this one is a wind box having like 5 meters and 2 meters of area. So it fails really quick, almost instantaneously in static, and in cyclic within 50 or 100 cycles. So that is a lack of understanding in that aspect. So for better designing, that needs to be understood.
No, I think.
Mine was really just a clarifying question that your work applies to the corrugated iron roofs specifically.
Not only to the corrugated. So typically, corrugated and the trapezoidals are mostly used.
Yeah.
So this applies to like the few profiles of them.
Right. Okay.
Yeah.
Okay. Thank you.